Yeah, so ladies and gentlemen, yeah, so this is another video. This is your tutor, Mr. Mwamba Jackson. So we have these two questions, which is coming from Math, year 10, advanced calculus. So we have these two questions on Laplace transform. So we go to question 1, which is solution. So now, before I go to solution question 1, we say the solution. We say 3 exponential t cos t squared. So now you need to understand this identity which is there as cos t squared. So first of all, before I go any further, I want to say cos t squared. This is the identity which is 1 plus cos 2t over 2. So now, since there is cos, so there the sign remains positive. Like that. So now, what if we add sine squared there? So sine t squared, this would have been 1 minus cos 2t over 2. So what changes there, ladies and gentlemen, is just the sign there, but the cos remains the way it is. And ends with the power they have given you here. They can even put power 3 if they want. So now, since we have this now, we can proceed. So which means where there is this, I'll substitute. Where there is cos t squared, I'll substitute this. So I have 3 exponential t multiplied by 1 plus cos 2t over 2. So multiply this. So this becomes 3 exponential t over 3 over 2, sorry, plus 3 over 2 cos 2t. So now I can proceed and find the Laplace transform of this. You want me to find the inverse, so I'll factor out this 3 over 2, then I'll get the inverse Laplace of exponential t. Then plus 3 over 2. Oh, sorry, this is supposed to be exponential t cos 2t, because this is multiplied in there, so we need to put the exponential. So even here we factor out the 3 over 2 Laplace inverse of exponential t cos 2t. So now, as we know to say, when we are told to find the Laplace transform of this, let me create some space here. We create some space. If you are told to find the Laplace transform of this, which is the Laplace transform of pt. So this we know is 1 over s minus a. So where there is a, we substitute the power of the t there. So as the power of the t is 1, so a in this case is 1. So over s minus 1. So that becomes the Laplace of this. So what about this part which is E? So this is shifting theory, because I have the exponential t and the cos t there. So now ladies and gentlemen, let me create some space. So let me create some space. So shifting theory. So we need to find the Laplace of this cos 2t. We need to find the Laplace of cos 2t. So the Laplace, where we say f of t is equal to the Laplace of cos 2t. So as we know, what is the Laplace of cos? So we say f of t equals s over s squared plus n squared, like that. So, which means where there is a, we substitute the 2 which we have there. So this one becomes as our f of s equals s, because it's shifted from t to s. So it becomes s squared plus, where there is a, we substitute 2. So 2 squared, which becomes 4. Like that. So since we are saying the shifting theorem, so shifting theorem, remember we have this exponential t here, which is there, where we know that our t is 1. So this becomes fs minus a as the shifting theorem. Where there is a, we substitute 1. The 1 is coming from this exponential t. So this becomes f of s, where there is s, we substitute s minus 1 over, even there, s minus 1 squared plus 4. So this part is what we substitute there. So we say we have found the Laplace of this. So the Laplace, they have told us to evaluate. They have said inverse, sorry, they want us to evaluate. So we find the Laplace on the inverse. So here, what is the Laplace of exponential t is 1 over s plus 3 over 2. So now remember here, we are finding the Laplace of this. So we have already found, the Laplace there, which is s minus 1 over s minus 1 squared plus 4. So we conclude our answer becomes 3 over s plus 3s minus 1 over 2s minus 1 squared plus 4. So this becomes your answer for question 1. So let's proceed to the second question as well, so that we understand the basics of this question. Okay. Right, so we proceed to question 2 as well. So question 2 is saying the one has to find the Laplace of that. The one has to find the inverse Laplace of this. So how do we find the inverse Laplace of this? So here you need to understand what you have. You have s minus 1 there. So you need to make this s minus 1 to look the same with the denominator. So there the same with the numerator. The numerator and the denominator, it should look the same like that. So you need to introduce some numbers which will make this to look in form of the shifting theorem. So what are we going to do? So let us proceed. We are going to factorize the 3 there the way it is. We do that. Then we say over s minus 1, like I was saying. This denominator, it should look the same with the numerator like that. Then you're going to ask yourself to say which number, when you multiply this 3s minus 3, you're going to automatically get this 3s minus 3. Now we need to find the number whereby when you add it, it will give you negative 7, like there. So there the number which I'll introduce is negative 4. So when I say 3s minus 3, this becomes 3s minus 3 minus 4. This will be 3s minus 7. It will bring me back to that. So this is the situation I was talking about. So that's what you need to do. Over s minus 1. So now you need to split this now. You say 3s minus 1 over s minus 1 minus 4 over s minus 1. So there you cancel, you remain with 3 over 4 s minus 1. So now you need to find the Laplace of this. You say the Laplace of 3 minus, there you say 4, the Laplace inverse, the Laplace inverse of 1 over s minus 1, So now we are concluding now. So the Laplace of 3, you say it's 3, then you say delta t, like that. So this looks like this, minus 4, the Laplace of this 1 over s minus 1 is exponential t. So this becomes your answer. So if you have any challenge, you may bring out, we share, we discuss together as a family. Thank you for watching this video.